So here we go. Good morning, everybody. I'm happy to be here. I hope you are enjoying your holiday. And today we are going to start our third, let's say, lecture about introduction to the geographical information system. Yes. Any question, first of all, before we start from a previous lecture or previous session or anything up to now?
No question, I guess, John.
Okay, that's fine. Here we go. So before I start, I'm once more wants to emphasize about the program. As you remember, I think also Dennis also asked us about the QGIS. As I told you, it doesn't matter which program you are going to use, ArchMap or QGIS. I'm prefer ArchMap because I am too much handy with ArcMap or ArcGIS. But of course, all of them same. But as I tell you, with your own responsibility, you can do with other program also. They are all same, but the function or the, let's say, process maybe or step are different than each other. But as I told you, I'm not too much handy with the QGIS. I'm also use the QGIS, but not all the function, just some of them. So that's all about it. I'm just go very quickly over the course what we done up to now. We just have an overview by previous session, what is the data, what's information, and what's the GIS application of it and component of GIS. We just start to give some information about the GIS definition. Then after we just talk about the history of GIS. The father of it was Roger Tomlinson. I was a Canadian. We just give a bunch of GIS definition to you, but we told you that the easiest one, you don't need to memorize. Just try to understand the logic of it. This is a system which is an integrated computer-based tools for end-to-end process. And you can do from one process completely to other process step by step. So what are the process? So in everywhere, like a site analyst or here, you first go to gather some data, or let's say capture it. After you gather, you put it in your paper, you store it, you record it, or whatsoever. And day after it, or after it, you just go and call your data, start to retrieve them, and after you start to analyze those data and then make or report. So the GIS is used for gathering this data or for this end-to-end process of a data using a location on the Earth's surface. And we use it to, let's say, automatic our process and also operation management and also decision making support for our decision. So we give a very brief things about the component and GIS architecture. This is the same thing as I defined a few seconds ago. So we talked that the important things for us is the data or data input. If we don't have any data, it means that we cannot do anything. We are trying in this course to gather the data, we put the data, we manage some of the data and analyze, and we make a output. But the output just have 5% value. Without data and without correct management of data, you are never come to the end. We talk about the 6 method of the data collection. We cannot say only for a geography. In our, let's say, field of work like architecture, planning, geodesy, geoscience, we all of them involved with this kind of method: GPS or global positioning system, digitalization, whether raster or vector, remote sensing data photogrammetry or aerial photography, scanner, a big scanner or big map scanner, or a small one, A4, which is you see in everywhere, and field survey, use of total station or leveling or other similar equipment. We talk about the GIS application. The first user of the GIS was John Snow. He tried to solve the London cholera epidemic. He was a doctor, and he used GIS as a first user, but he didn't know anything about it. But he didn't know that this is a GIS actually. Not he didn't know anything about it. So we are talking about different discipline of the GIS. We say that we have different application area, computer science, management, and geographical related things. Also, we just give some of the example for a real term, like the city information system, campus information system, traffic information system, logistic information system, land inventory, forest information system, and etc. Also, we determine, or let's say we categorize some of this real-term application based on local government, state government, business, military and defense, and science research. And these are other ones which are typically used in TRNC, Turkish Republic of North Cyprus, in Kakatice. We use a system information system. Recently, it is by like 6 or 7 years ago, this system started. I think in magusa.org, if you go to the website, you can see this infrastructure management, and I cannot say definitely infrastructure management. They just put the pipeline, the water pipeline, and the building numbering and parcel. So later we just talk about the component. We have 5 important components: people, software, hardware, method, and data. And we define each of them: hardware, any tangible part of the computer. It can be a, let's say, a hard drive, monitor, motherboard, or any server, desktop, or anything. It's a software, the things that you know. It can be a protocol, it can be an operation system, it can be a script plugin, and etc. We have 2 types of the software in everywhere, not only in GIS. We have commercial software and open source software. We quickly discuss about the benefit or advantage and disadvantage of the commercial software and open source software. After that, we talk about people. We need a bunch of different people as a system administrator, system analyzer, database administrator, end user, and etc. Also, we need a different method for a management, for quality management, risk management, time management, human resource management, and let's say GIS operation management. So I think we stop here last session. So let's now start from here. Here is a, let's say, important part that we are going to talk about it. Up to now, we just give a brief information what is a GIS, but from now on, here is a, let's say, the main body of the course start from here, because up to end, we need to understand all these things. What is a spatial data? What is a descriptive? And this kind of thing, because up to end, we are going to use this thing. So if you remember, when we talk about the data at the previous course, data can be any qualitative or quantitative. It can be a word, fact, number, raster, picture, or any measurable things. So we are work on the data, and after that we generate information. So in terms of GIS, when we come to the GIS, or Geographical Information System, we have 2 important elements. One of them is spatial data. I think all of you know that what is a spatial data. Spatial means that anything that you can geometrically address to it, or you can find the location of it. So all of you as an architecture, you are working with spatial data. For instance, imagine I am just put my pen or pencil on the table. So easily you can give an address to it. You can say from the, let's say, left down corner of the home, we have 5 meters to your pen, and from right top of your right top of the room corner, we have like 8 meters to your pen. Or if I want to ask you, let's say Magem in Famagusta, all of you can define an address. You can say you need to go straight away toward the Sulu Chamber or this mosque square, and you can find, like after you pass 3 o'clock from EMU to the mosque square, you can meet it in your tree or in your, let's say, right side. So this means that this is a spatial data, so you can give address to it. Or let's go now mathematically, you can define it in a Cartesian space. You can say the x and y or z of this element is located there. Now let's I just give you very since you are working with AutoCAD, I'm going to tell you how this works in AutoCAD also. So this is a spatial data. You need to learn what is the difference between spatial data and non-spatial data. For instance, sound. You cannot define the sound location. You can just say that this sound coming from that direction, but you cannot specify the location of the sound because it is go on the air. Or light speed. You cannot say this light speed or this light which is coming from the sun on the air locate there. No, you cannot. But of course you can define location of the source, not the, let's say, movement of it. So let's say if this is a typical AutoCAD, yes, just wait a second up to this AutoCAD open. I'm going to work. I'm just going to start to explain from AutoCAD, maybe because this is same, let's say, a structure that AutoCAD also use, same as GIS, but GIS of course is too much strong. But here I just let's say open something that I have, maybe this one, to just show you something. Okay, this is good. So as you can see here at the down, we have some coordination, we have a spatial location. It means that when I just start to draw, it tells me that I'm going to start from 30x and 7y point to the next direction that you wish. As you can see, I'm just now lock my oil snap and my X direction is now locked. I can just move in Y direction. So I can just say, okay, let's just move 5 centimeters to the top. So both of these points, both of this start and end point have a spatial location. But this is a local data set, which is here is a 0.00, and as you can see the Z also 0. But if we work in the real world, we need to set ourselves with a geographical spatial location, not a 0, 0. Because if you start to draw from a 0, 0, where is the 0, 0? Because this is your definition. And if you bring it this, let's say, coordinate or this spatial location to somewhere else, they cannot understand you. So that's why we need a spatial location. So this is first thing. Every map object, or let's say point, because always we start from point. As you see here, I'm just randomly, I'm just in my canvas, and just choose this point and move towards the next direction. So this is called spatial data. But what else we have? It's a descriptive data, or in some GIS they call it attribute, but in some they also call it descriptive. What does this mean? It is a non-geographical element. It means that this is not spatial, first of all. You cannot geographically address to it. But this is the things that describe your spatial data or your object. Let's come back to the pen. If you remember, I said I put my pen in my table. So imagine now I'm going to describe my pen. For instance, this is our pen. We are just talking about it. I can say that this is a ball pen. This is a red, with a red color and almost, let's say, 20 centimeter length. It is old. So everything that describe this object or this map or this data called as a descriptive data. Now again, come back to the AutoCAD. So here we just draw a line which have a spatial data. What is the attribute of it? They have lots of attribute here. If you just open the property, these are up to here is the attribute of this line. You can just say it is warped by layer color, which the layer have a red color. You can see that the layer is a VCC. Again, line type is based on the layer. We have a line type scale like this. We can say that the line weight thickness, what is the thickness of it? If we have a hyperlink, we can click on the line. It is take us to the, let's say, information on the web, and etc. Anything that we are going to define this one as a description is called attributes. So these are all the attributes of this line. Any object, for instance, if you just, I don't know, I just draw a random ellipse. So this also have a different attribute, but this part is a geometrical information. Okay, I think it's understandable. So it is same as GIS, same thing work in GIS. So we can say that the GIS data model, how the GIS data model implement, we can say that GIS integrate spatial and attribute data together in order to display and analyze for us. So, and later we will see how this data, how, let's say, this data integrate in GIS. But I'm going to show you later. But as you can see, we have a table for each, let's say, object. Like here, for instance, in AutoCAD also we have this table somehow. So each object, if I select, we are going to go to the table of that object. So now the things that GIS do, it's bring different data model. It's organize different things. For instance, I'm just go to the Google Earth. I have something here. Yes, I have. So let's open that one. I'm going to show you what is the data model. So we have a different layer in GIS, exactly like a AutoCAD. For instance, I can switch off this one. As you can see, the devices disappear, mesh, and a target. So different thing, it can be open on the layer, again like a AutoCAD, like a like a Google Earth. For instance, let's go to the Cyprus, to the let's say to the Famagusta or Castle. So here we have a bunch of layers on top of each other. This is also a commercial version, a Google Earth. So if you just open a different layer, and just turn off this layer, or I'm just turn off the road layer. Of course, here we do not have an infrastructure layer, but you can put a bunch of layers on top of each other and make a GIS, like here. The digital, let's say orthophoto, we have digital orthophoto here. This is our background. This picture is a digital orthophoto, or later we call it raster. Then you can put a street, hydrography, parcel, building, zoning, utility, administrative border, and etc. and etc. This is just a simple example. And with use of this thing, you can present the Earth in a very real manner, or your model in a very real manner. So we can say that the GIS is organized by layer and different coverage or themes, and each layer represents a feature that they are common on it. For instance, street. In a street feature, we always put street, nothing else. Or with a parcel, we always put a parcel data. So, yes, this is up to now. Now I'm coming to the GIS model. So, in order to present a very, let's say, simple GIS model, we need to have a street data, we need to have a building data, we need to have a, let's say, vegetation or green cover or soft cover data. When we integrate all of them, we have a real world. And each of these, let's say, data sets doing or prepared by someone. For instance, vegetation data created by a forestry, let's say, organization, or building data by municipality, or street data with, let's say, traffic organization, or etc. So after that, we get all these things from different, let's say, authority, and then put it together and make one integrate data set which is represent our real world. But now come to the layer. We just talk about the different things, about the different data, spatial and descriptive, and this, let's say, geographical data start to shape our layer. Now we are going to talk about the layer. What is this layer and how they are working? We have two, let's say, graphic feature in GIS. One of them is a vector format. The vector format is based on the mathematical system. It's used for represent entity, any entity. It can be point, line, or polygon. But we have some different sort of layer which is called a raster or image. The image or raster store the value or data in a pixel format. So, and these two layers are integrate spatial data and attribute data. We will going to see how. First of all, before start, we have an entity representative. We have point. The simple element in the word is point. As you can see, I'm just start from one point and then reach to the second point, third point, and last point. So, yes. So point can be used to identify a specific location, like a node, like a peak, a mountain peak, like electric pools, or let's say water well, or volcanic cones again, one tree, or one gate, or a crime scenes. So all of these are a specific point. But if we continue and use a second or third or five, we start to draw a line or arch. This line or arch represent our road, river, telephone lines, or creek beds, sewer line, power line, anything which is linearly continue. Coastline, let's say also. So anything that we are not stop, for instance, up to when I just go, this is a line, you know. But as soon as this line become close, it starts to represent a polygon. We use polygon to represent a land, parcel, or country, continent, forest, a rock, or boundary of the, let's say, garden. All this represented by polygon. This is very important. Maybe at the beginning look like very simple, but at the end, most of the time we face a problem with this. For instance, let's tell you why. Because you are coming from architecture mind, when we talk about street, you are start to draw a pedestrian line, which means that you start when I said, okay, bring a, let's say, street, you start to draw something like this. Let's say I'm just draw something very simple, street. In a GIS, this is not a street. We are not called this one street. So this one, let's say if we continue it, it is one urban block. Okay, so these are the difference between an architecture term and, let's say, a GIS term or geoscience or in our field. So that's why, please, this one is very important. You need to understand the usage of it. For instance, for a point where you are going to use, or for a line where you are going to use, or for parcel. So we need all these elements together to represent a real world. So now come to the vectoral model. In a vectoral model, we use X and Y in order to represent a, let's say, point, line, polygon. Exactly same things that I'm just do it in AutoCAD. So each of the point or each of these stop, let's say, point, of course here is a vertex in a AutoCAD, but we have endpoint and start point. Each of them have a X and Y and Z. So these are help us to, let's say, specify or represent a location with use of vector model. But what is the benefit of the vector model? If we talk about a vector, first of all, vector is a discrete property which is reflects the real situation. You can just easily, by looking to this image or picture, say, I don't know, this part is a desert or sand, this part is a forest, let's say. It's reflect the real situation. The data structure always complex, okay, because you need to have a different sort of data in order to represent your situation. Simulation is difficult, and due to the different topological structure. Let's tell you how. This is AutoCAD. This AutoCAD is a vectorial system. It is vector-based system. So the simulation is difficult because you need to use the program, those who can interpret the DWG or drawing. Only with that sort of program you are able to simulate it. Okay, we are coming to that. We can understand what's the difference between raster now. You can assign a bunch of attributes to it, like here. You see, we just assign a few of them because AutoCAD have a limitation, but in GIS you can assign thousands, millions of the attribute to any object, any vectorial, let's say, object. So it have scale accuracy for a geographical representation. What does that mean? Imagine as much as I zoom to this object, still the quality not lost. You see, if until tomorrow I am start to zoom on it, still I have high quality because it is a vectorial and mathematical, based on mathematical, let's say, calculation. So it is good for storing a discrete thematic feature. What is the first of all discrete? We have two sort of property. One of them is a discrete, one of them is continuous. So discrete data is like this. You can just define the boundary of it. Let's tell you something like this. The population of the world is discrete data, or family member, or your, let's say, yes, family member is a discrete data, but your weight, your height, or let's say your age in some instance are continuous data, or temperature is a continuous data, or let's say again length is a continuous data. I'm going to explain more in the raster. So about the raster model, we are working with let's say image or digital value number. If you just, let's see, yes, let's call it, this is a raster, this is a raster, actually this is a raster. So just go inside of it. Actually I cannot go too much with this program, but maybe you can see start to be show each digital value or each pixel. Or if I just open the property of it, it's going to tell me that it's have 960 pixel in a X dimension and 960 pixel in a Y dimension. It means that if I'm start to count, I can count 960 pixel in this direction and 960 pixel in this direction. So it is like a table. It is like a table have a 960 column and row, like here. So to represent a point, we need to just draw one of the pixel. But if you want to show a line, you need to draw a few of them in a linear manner. But if you want to represent a raster, a polygon, you need to draw a bunch of them in order to create a closed boundary. So this is about a raster. So each of these points can get one digital value or one digital number. This value could be from 0 to 255 RGB value or red, green, blue base. And each of them, of course, each of them have X, Y, and Z value too. In a Cartesian system, like the ones that here we have, our X and Y start from left down point. But in a, let's say, a raster, let's try to create a raster. Let's say this is our raster. Let's quickly draw it this way. And also for this one. Yes, here we go. Let's move a bit. Yes, the raster data set start from top left point. Sorry. Imagine this is our raster. We have, let's say, 15 pixel in the, let's say, left to right, and we have, let's say, 15 pixel from up to down. Okay, so start from here. If you want to draw something, the raster start in that way. For instance, you just, let's say, solidly hatch. For instance, 1 pixel, I'm just draw 1 pixel with this color. If I'm check what is the color, you see each of this color get a value from here. You can see each of this color get a specific color based on the RGB. For instance, red, you see 255, but the other is 0. But if I want to make a green, I need to take this one to the 255 and the other to the 0. So each of these pixel is represent for one, let's say, digital value. In this way, I can draw a line. Now, come back to the presentation. So, what is the advantage and disadvantage of the raster? First of all, it is most common data format. If you take a picture with your telephone camera, if you scan a data, if you look at your computer, you can find a bunch of raster. And you can open it everywhere in your telephone, in your camera, but the vector, you cannot easily open it in your, let's say, telephone, because you need to set up a specific app or application like AutoCAD or etc. Data structure is very simple. We have a table of pixels like this one, and you need to just start to draw them. It is very simple. There is no mathematical calculation like a vector. The pixel size, if you take a pixel in the same size that you start to simulate, it is easy. But for instance, let's say my object is a 10 centimeter by 10 centimeter, and assume that each pixel have 1 centimeter. If I use the raster with 10 by 10, the simulation become easy for me to capture the data. But by increasing a pixel like this one, our value going to be lost. For instance, if I am 100 or 200 times zoom into this C, everything going to be lost. We cannot understand anymore this is a C, because thus the color going to be meet each other, different color. Always big space required to capture. For instance, let's tell you something. If you just going to print a A0 drawing, AutoCAD drawing, maybe it is just a 100 kilobyte or 200 kilobyte or maximum 1 megabyte or something. But if you want to print a Photoshop poster in A0, dependent to the DPI, it can be from 100 megabyte to the, let's say, up to 1 or 2 gigabyte. It is better to represent a continuous data. For instance, if you can see, this is a gradient, it is a continuous data. It is work like continuously from here, slightly yellow, again slightly dark, and then up to brown. But here it is discrete. It is cut exactly in this, let's say, boundary, or this is cut in this part. We call this one discrete, and this is continuous. We are using to present a height, a slope, solar radiation, or etc. for a continuous raster data. Of course, this Google Earth, this one, this is a raster data. Imagine if I am start to zoom more, the pixel value going to be lost and lost. I'm going to see, of course, this is turn it to the ground, but as you can see, the pixel, the value or quality going to be lost. This is about the concept of the vector and raster. Imagine we have you want to present a raster. As I said, it is start from top left if you want to fill the raster data, but if you want to fill a vector data, it is from vice versa, from left down. So we want to say, let's say we have a house here. For a house, because it is a specific point, we always use point. We just say house or house, let's say H. We have tree, a few tree. So we use a boundary because it is more than 1, so it is 2. It's have a boundary now. But if it is 1, we can use also point. So we use a, let's say, polygon, as you can see here, polygon. So also we represent with a T, TT or 40, like this. Or we have a river. In the real world, it is like this, but in a vectorial, it is like this one. And we presented the vector one, the raster one in this way. Again, the attribute data we have for a vector and we have for raster. Maybe you think how you are going to integrate the attribute data to the raster. You can easily understand which raster you are going to work. For instance, you can say the raster, the pixel point, let's say 1 and 2, which means that here, or 2 and 1, which means that here. Accordingly, you can assign an attribute that you wish. For instance, you can say that pixel, it's a green value, have a this data, it's a tree, or it is something else. Same thing for vector. Of course, for a vector, it's too much understandable. You start to assign an attribute from here. very easily. So both of them, vector and raster, can be assigned attribute data in this manner. For instance, just look at here, we have some street. For instance, the address is Circuit Street, Plain Street, Webster Street. We have different streets. So you can say this family, for instance, John family, they have 4 family members. They are living in a 18 Webster Street. Or same thing for, let's say, monitoring wall, or for industrial zone, we can say that Westlake Street is a Fox industry. They have a Fox facility, or there is a factory of the Fox. So as you can see, when we have a raster like this one, and when we have a vector, when we integrate it with an attribute, we can present a real world in this manner. So this is up to now. This is all the things that we need for using a GIS or geographical information. This is all the concept that you need. Any question up to moment about raster vector?
No, Hajam, I guess.
Okay, so now let's start with, I'm just briefly going to show some feature of the geographical information, and with coming section we can go start to work with it. So sorry, just going to mistake. So this is a typical ArchMap. Actually, we have a different bunch of the application inside the, let's say, ArcGIS. If I can find it here, as you can see, we have an Arc catalog, we have a help part, we have administrator, document defragment, Arch Global, ArchMap, ArchSense. All of them useful for some instance. But we are going to use this ArchMap or maximum ArchSense for those who wants to work some 3D or this kind of things. But our course is mainly developed with ArchMap and Arch Catalog. Actually, Arch Catalog is located inside the ArchMap. So the program, as I told you, I'm using 10.02 of the S3. If you get the message of loading document, it means that everything load very good. I'm just close some of these things in background in order to save some memory. So this is an ArchMap. This is a typical ArchMap. As you can see, it is not use a ribbon system. It is very, let's say, a typical one. Of course, the ArchMap Pro, the new version, which is released since 2 years ago, it is also compatible with macOS. It have a ribbon system. But the ones that we have it here at this moment, this is a simple one based on the COM architecture or component object model. When you just come to the ArcGIS, this is the path that your data going to be set, and this is the geodatabase or GWB that you are going to work with it. We have some template. I'm going to just start with this template, this session, and we have some ready page or ready template like this one. For a beginning, you can start to work, for instance, this kind of template. And also we have some traditional layout like this one. We can use for PowerPoint presentation and etc. But right now, I'm going to start, or I'm going to open one of these map at this stage. Let's see this Europe. Okay, I'm just hit OK. And the Europe going to be open hopefully in a few seconds. Yes, here we go. Let's just close these things, because at this stage we are not going to use this kind of things, but time by time we are going to see what are those things. So this is a typical GIS interface. We have a table of content here, the ones that we are going to use. Most of the time you are suddenly close it. If you close, don't worry about it. You can just add it again from here under the window. You can add a table of the content. You can change the view of it based on the geodatabase, based on the layer, and based on the content, or based on the different other option. It doesn't matter which one you are going to use. Unlike any other program, we are not going to use save. Actually, it is rarely we are going to use this save, because this program is a bit different. This is the first thing that I'm always explaining to a student. This save just save a current map. That's all, not our data, because we are going to work and create this data. This data, the creation, the save, edit, manipulation is done from somewhere else. But this one just save our current map, the map that right now we have. Let's put this on top. So as you can see in a top here, actually, we have a coordinate, the ones that I'm talking about it. Each point in the world have a specific coordinate, but also in here we have an inch. Of course, we can change it from ArchMap option from inch to centimeter. Yes, like now. This is my page dimension, the page that I have, the poster dimension. If I put here, it is 0, 0. If I put here, it is, let's say, 2796. And if I put here, it is 21. It means that this is the A4 page, because it's 21 by 29. So this is our map. If we want to make a report or submit our final project, we use this area and use this save. This is our last step. But the things that we are going to use mainly, we are going to use a data view, not layout view. As I told you, this save just help you to save this current layout. So to create or to generate the data, we are going to use this data view. This is data view, and if you can check here, we do not see anymore a centimeter, just the coordination. Of course, you can also switch between layout view and data view from here. The data view, the view, or let's say canvas that you have your data or raw data. But if you want to make output, you are going to use a layout view. So let's just come to here. If you check here, you will going to see that we have some entity representative. We have a city as a point. If I'm just turn off the city, you are not able to see the city anymore. I'm also going now to open it. You see, each city can be seen here. If you remember, I told you each of these, let's say, entity have their own attribute. We have an identity or I here. You need to just move and choose, let's say, Warsaw. Let's see what we are going to find inside the Warsaw. We find that the Warsaw, it is point, first of all, as a shape. We have an ID. Later I'm going to tell you what is the ID and what is the object ID. This is a field ID, this is an object ID. Later I'm going to tell you, but right now just accept as it is. We have name, of course, Warsaw, Lodz, Vienna, or Berlin, whatsoever. We have a population, it is Europe. We can add a bunch of other attributes here. We can say that it is a cold city. We can say the language is, I don't know, Polonian. We can say that it's have a friendly people. Many things that you wish. You can add here. So same thing for other. For instance, let's say fine. Here we have a grass. Again, it is in European, we can say it's Austria country. If you see the object value and field value is changed. The population is 325,000 people, or etc. Or Vilnius in Lithuania. Where is it? Hello, what happened? Can you hear me? I think our network is bad.
Now, yes, we can hear you, John.
Okay, that's fine. So, as I told you, I don't know, it's writing here bad network. Well, I hope I hope there's no problem. So anyway, so any of these, let's say entity, we call them entity. We have a point entity, we have a line entity, and we have polygon entity. So for instance, Minsk or Vilnius, as you can see, they are all located under the city. We can have many points here. We can have many different layers here accordingly. So again, same thing for, let's just turn off some of them in order to save some memory. Okay, I think it's not bad. For instance, we have a river. So if I just click on the river, I don't know which river is it, Danube? Yes, it's Danube. So if you just choose the river Danube, it's tell you this is the name, is the Danube. You can say it is located in Europe, it is coming from Germany to up to, let's say, Albania, and you can say that it have a, let's say, 3,700 something kilometer length. You can say the width of the Danube is, I don't know, in somewhere it's 20 meter, in somewhere like 30 meter. You can say it's deep, it is dangerous for swimming, and bunch of other attributes again that you can add for this linear object. This is our linear entity, or this is our linear, let's say, object. Or another river, this one, the Rhine. The Rhine River, it's 1,770 kilometers. You can say that it's coming from North Sea, and it's almost finished in a sort of Germany. So you can add other things. As you can see, it is located under the river value. It's have again an object ID. So this is about, let's say, line or polyline. In some, again, in some GIS program, I'm not remember exactly right now, I think in a QGIS maybe, or in UDIC, they call it as a line. But here in in ArchMap, we call it polyline. Polyline or line, it doesn't matter. Both of them are same for us. We have lake. Let's also close the river. We have lake. Right now I'm just close the lake. Let's open it. Definitely we have We should have some lake somewhere. Yeah, like this one. So this is a lake of one area. Its depth is 325 meter. The surface elevation from mean sea level it's 144. The area of it is like a 2,329. It's not mentioned. Definitely it's kilometer. So this is the area of it, the shape area, the length of it, the perimeter length of it, and other information that you can get. Or same thing for other river, other lake, like this one. It is Lake of Ladoga. Again, deep of it is like 755. The surface level is 13 meter above the mean sea level. So again, you can add a different bunch of attributes, but I'm going to tell you how by coming session. Now we are just trying to observe. So as you can see, the layer, you can move them. You can take this one, bring it down. Of course, if I bring it under this Europe, you cannot see them anymore, but the label is available. You can take them up accordingly from small to the big. You can order them and put them accordingly. So now let's come and continue. We have scale, map scale. You can change your map accordingly. And right now we are in 1/20 million. You can do it 10 million. Of course, it's become big. If you can, if you make it 250, it's like very small, which is nothing seen. Of course, 1 million too. So you can accordingly manage your, let's say, scale from here, or you can write the scale that you wish. For instance, I want to say, I do it 50 million, 1, 2, 3, 1, 2, 3, like this. So you can manage by yourself. We have a mouse, the select element. This is useful for select the element. Actually, if I'm select right now, you can see nothing will be select, because this element is useful for data view. I can select now Europe. I can move the Europe here. I can put it here. I can move the north sign to here. I can change the legend, and this scale bar, I can put it here. So this select is work in layout view, not in data view. Please never mix these two together. Imagine, or this function, if you see we have two different magnifier, plus, minus, or we have two pan, but in data view, if I'm just, let's say, switch to data view, this one become disabled. I cannot use it because these data plus this element, select element, belong to that part. Zoom in, zoom out are the simple thing, of course, you know. The mouse movement is different than AutoCAD. In AutoCAD, when you turn it towards down, when you turn down the screw, it's zoom, but here it's different. Maybe first day it's a bit weird for you, but later you become easy and handy with it. We have pan like AutoCAD. We have a full extent like a zoom extent. If you press it, all the data that you have, it is fit in your current canvases. We have fixed zoom in, which this one based on the scale. You see, according to the scale, I'm zoom in or zoom out. But if I use a magnifier, it is just something out of, not out of a scale, but the scale is not, let's say, rounded. It is 1/5 million something. It is not round. But if you use this one, it is going round and too much logical. With use of this one, you can go to the previous extent, like here, or you can go to the next extent. For instance, if I'm just move here and I want to come back to the previous, I can just use this one. So we talk about this and this one. These are, later we are going to understand what are these, this selected feature and this clear select or unselect. These are, which is now is disabled, it's useful for a data view. However, this one, select element, not feature, these are the feature. Feature work with the data view, element work with a layout view. The identity, we are use it somehow, we understand what is the identity. We have measurement, we can going to measure from one point to another point. It's tell you the length. Of course, you can start to make a close measurement, or you can make some distance, area. You can change the unit. You can close it. For instance, this is a area one. It's tell you the perimeter is a 680,000 meter, or the length of the last segment, and the area is 24 million thousand square meter. So this is for measurement. This is for find any feature or place in geographical, let's say, information system. You can looking for a feature with use of this function. We have, I think my computer was freezing. Actually, I shouldn't open the find. We are normally not use this find. We are going to use a selection, but I'll tell you later. Just be aware what is a find. You can find anything. It's like a Control F in a Word or Excel. You can find a feature in a visible layer, in all layer. I'm not going to choose it because my computer is going to freeze, but you can check it in your home. You can looking for a different location or feature. This is find the route. Maybe you saw this one because right now we don't have any route here. This is about the street. Definitely you saw it in Google Earth. For instance, if you want to say, I want to go, I don't know, let's say from EMU to the İşbankası or to the castle, this find the route in a Google Earth start to draw a path for you or alternative path. This is same as there, but since we do not have any street right now here, so that's why it's not work at the moment for us. This is for X and Y coordination. For instance, you want to find specific point. Let's say I'm going to find a longitude of the 15 and latitude of the 54. Just make a flash. It's tell you the location is over here. So you can change the unit from degree decimal minute to degree minute second, or decimal degree meter, UTM, MGRS, which is military base. You can add a point. For instance, I can just add a point there. You can see I just add there, or I can add, I don't know, something else. Let's say I add it in 13 also, which is here. So you can add a different point also. You can add the location of it. You can add a label and etc. It is not bad to find a quick spot. If you want to quickly find a spot, it's not bad. It is like a GPS. It is work like a GPS. So This is a time slider. Fundamentally, let's give you an example of the time slider from the Google Earth, because this function also not work because we do not have any time series data here or any longitudinal data. Imagine this time slider or time series. It is like exactly this. Just quickly come here. So with use of this, sorry, not this. With use of this time series or time slider, you can move during the different time or different time period. So you can see that there is a new development. Let's see here, maybe in the scale. You see these are empty, but right now start to build in this area. So this is like a time slider, but here we don't have such a data. That's why this is not work at the moment. We have also current view. This is for current view zoom. It's make let's say a zoom on a specific point that you want, like this one. It gave you a zoom when you want to work in two different pattern. As you can see, if I zoom, it show you where I am zoomed. If I am open a window, it's show you where I am open my window. It is good for when you want to work in a 2 or 3 point at the same time. So also there is a magnifier. I think my computer again freeze. Yes, a magnifier here. You can also put this magnifier and change the zoom level of it, of this magnifier, same thing. So this is about this up to moment, but let's go also to that layout view. In a layout view, as you can see now, layout view active, especially this navigation function. If I am use this one, I can move my paper, let's say, or I can zoom to my paper. You see, this area is not changed. I can zoom extend to my paper, or I can move. But if I use this one by mistake, this time my data going to be zoomed. You see, not my paper. I'm just making a mistake and choose this one. I want to zoom to my paper. Let's say this area. However, my data going to be zoomed. So just careful about these two differences. Same thing for here. Again, if I am choose this one, my data going to be zoom or zoom out. As you can see, the scale also change. But if I am use this one, my paper going to be zoom or zoom out. This is only a big difference among these two. So I think for now, I'm just try to explain the GIS data set today, and also we're just coming to see the navigation. I hope it's coming week, and all of you have also GIS, you will set the GIS. We are able to work with some real data and see how we can do some project inside the GIS. So up to now, any question by the moment? So any question up to now? No question? Any other question? If not, I can stop our course here and wish you a good weekend for all of you. So I think everything clear, no any questions. So I'm going to stop here and wish you have a good weekend and be safe for all of you. Have a good weekend for all of you. See you by coming week.
You too,
Bye. Bye bye all of you.
See you.